Alright, hello students, this is Mr. Cootsie. I'm going to explain a couple things here. For chapter 1.5 in the Math 2 book, rational exponents and radicals. So a couple things, rational, that just means it's a fraction. We know what exponents are. We haven't seen radicals, but you have seen them before. They're things like the square root. It's like the square root of 4, which is 2, things like that. Okay, so what I want to try to do today is explain some of the stuff that's in the book, because I won't be here tomorrow, so I want to sort of do that. So first things first is our rule. We had some other exponent rules in the booklet. If you still have your exponent booklet, this little Laws of Exponents book, this is a rule that's not in there. So this is one extra rule. Okay, what the rule looks like is this. If you have x to the a over b, by definition, as soon as you see a fraction, you're going to have a radical. That's the definition of how we work with these things. And what it is b is the index, x is the base, and a is the exponent. This is the format we will always use. Now, for a lot of this, you're like, what the heck? Well, for square roots, the index is 2. For most of what you ever did in Math 1, the index was 2. So what we're doing here is we're just stepping up to a higher level index. Okay, so we'll start with some ones we know, and then we'll step it up a little bit. So, for example, if you had 9 to the 1/2, by definition, that's the second root of 9 to the 1. Just following this format. And you got that. Well, 9 to the 1 is just 9. And if it's the second power, we usually just write it like that. Square root of 9, which is then just 3. That's it. Okay, so that's how we start it. All right, and now let's go through some of the more tough examples, because I know you're already familiar with square roots. What are you doing as the third root or fourth root? Okay, so for example, let's see. So let's try 16 to the 1/4, for example. 16 to the 1/4, by definition, becomes fourth root of 16 to the 1. Try this way. Sorry about that. And then, well, 16 to the 1 is just 16, so you take the fourth root of 16. Now, this is going to require us to sort of rewrite things here. We're looking for something of the fourth power. That's what this index means. Okay, so how this works. It's not a square root, it's a fourth root. So we need 16 to be a multiple of something to the fourth power. So here's how we do this. Break down 16, and that could be 8 times 2 or 4 times 4. If you do 4 times 4, then you can break this down to 2 times 2 and 2 times 2. And if you look in that row right there, 16 is the same as 2 times 2 times 2 times 2. Or we could say 16 is the same as 2 to the 4th. Okay, so what happens here? Fourth root of 2 to the 4th, these are opposite operations, just like square roots, but fourth root cancels out the fourth power, and you're just left with the base of 2. The fourth root, the whole radical, cancels off the fourth power here, and that's what it is. Okay. Now, if that looks kind of weird to you, remember, you already know the square root of 25 is 5. You've probably done that enough, you already know, you're not even thinking about what you're doing. But what this really is, square root of 25 is really the second power of 25, which is 5 to the 2. And the square root cancels with the exponent, and you're left with just 5. So this is essentially the same idea. Okay. Next, let's step it up a level. Let's say we had 16 to the 3/4 power. Okay, this is a little bit tricky, but it's the same idea. 4 is the index, 16 to the 3rd is inside. Whoops. Okay. Now, I don't have 16 to the third memorized, so I'm going to turn on the calculator. 16 to the third. That's 4,996. 4,096. So you could do the fourth root of 4,096, but you're still going to need a calculator for us. So there's a rule of radicals that says this. The fourth root of 16 and third is really the fourth root of 16 to the third. These are both equivalent, okay? You could try it on the calculator to verify it, and we'll verify it in class. But for now, try to take my word for it. This exponent here, it would end up being the same. The reason we want to do this, we already did fourth root of 16. That's the fourth root of 2 to the fourth raised to the third. Okay, so a lot of stuff going on here, so I make sure this is all straight. A lot of stuff going on here, so what we want to do is step by step by step. Fourth root cancels fourth power. The inside goes left with 2. Outside you have 3. And there you have 8. 8 is your final answer. Okay, so that's a lot of sort of what the examples are going to be, and then the homework is going to be. It's going to be stuff like that. So try this. That's what we're going to want to try out. We'll go through one more example, and I think you'll find the homework's not too bad after we do that. The only other thing we're going to do is let's show you a little bit about how the calculator works some more. So the book might say like the third root of negative 216. And again, this is not something I have memorized. 216 is a little bit beyond our multiplication tables, and third roots are not something I memorize. Okay, so on your calculator, you're going to want to try a couple things. And here we go. We have a square root button here. I don't know if you can see it. Square root. And then right above there, there's a third root. So if you have a calculator like this, you probably have this feature. Okay. If you don't have a calculator like this, borrow one from a friend, or we're going to have to do it by hand or some other method. But for this, because that's the extra function, that's going to be shift. That button, that's the third root. Negative 216. Oops. Let's see if we can delete that. Delete 216 and negative 6. Now, if you're like me, well, how the heck do I know if that's right? Well, the only way this can be right, what must happen here, 216 must factor into 6 to the third. So negative 6 to the third will be 216. And again, I don't memorize that, but you can verify with the calculator. 6 to the third should be 216. Third root, third power, cancel each other, and you're just left with the base inside. So that's it. Hopefully that'll help you with the homework questions, and you guys will be successful. Come back, bring questions to class, and we'll try and help you out with those. All right, you guys, have a great afternoon.